very much. I've got the tummy rumble slot. That's not my usual position in conference or whatever, but I represent research centre at Edinburgh Nippy University called the Wood Studio. If I can work this, it's one of 4 specialist research centres we have in timber research in the university, and the remit of my centre, I'm an architect, is to initiate remote innovation in the use of timber in architecture and construction. And we have all sorts of competencies in a number of areas in that. I'm saying this by way of background to 3 ideas that we have about Horizon 2020. So we really have become a kind of bit of a UK kind of epicentre of all aspects of timber design and construction. And we operate a programme of CPD across the country. And that is quite important to us, and I'll explain why in a moment, because we run an ERDF project called the Wood Products Innovation Gateway. It's a bit of a kind of lump and handle, but it's a 1.48 million programme we've run for the last 2.5 years. And the plan for this was to develop 20 or more new products, process improvements, or construction systems with Scottish grown timber and bring those to commercial reality. And we also were looking at setting up research networks for new ideas, different things that we were taking forward. The CPD is very much allows us to engage with lots of SMEs and to put ideas out, get ideas back, and begin to filter down those that we have the potential to work with. So we're working with quite a lot of SMEs at the moment, and some of them are very small, but some of them have the best ideas, in fact. And to take an example, really, the kind of work we do a lot of work, consultancy, even expert witness work, I have to say, on external timber cladding in buildings. You've seen it all around in cities and in the countryside and so on. It's become very, not say fashionable, but usual on a lot of buildings these days. And we've done a lot of research in this area because for 10 years ago, 15 years ago, your average building contractor thought it was just simply like nailing kindling to the wall. And not a lot of expertise, not a lot of understanding. We've been working on this, we've done a lot of research to advanced weathering tests and so on. We're leading on writing new British standards in this area because there aren't any. And we're also doing, we have a small project working, I said at the bottom, commercialising the offset manufacture of charred timber cladding. Grand designs and programs like that make odd things quite popular. And burning the surface of the timber has been something that's come up in the last couple of years, and I had a lot of inquiries from architects about this because they were getting building contractors to stand on a building site with a blowtorch burning the wood, which wasn't the brightest, cleverest idea. In Japan, they've been doing this for hundreds of years, so we've been looking at that and how to do it here, working with a small hardwood sawmiller to do that, and finding that the potential market for it is huge. So we're now working with a lot of small hardwood sawmillers to get this into commercial production. We produce publications on all of the kind of research and development work that we do. We do lots of other publications for other agencies like the Forest Commission and so on to get more information out there to SMEs and others to really to improve technical expertise, to improve knowledge, improve building performance. I mentioned networks. We're doing a whole range of things on solid wood systems. I won't bore you to death before lunch about all of that. But one of the things I want to just mention here is dowelled systems. And we're making cross-laminated timber from short lengths of timber from Scottish timber. We're making glued systems that are held together by dowels, where the moisture content of the dowel into the other timber is different, so they hold together like traditional construction when the kind of wood dries. And we're also making nailed stack plank systems. So looking at all sorts of solid timber systems, because you lock up a lot of atmospheric carbon dioxide with solid timber systems. We can also build higher than we can do conventionally. In Scotland, we build housing up to 7 stories in timber frame, but beyond that, there are technical issues, and structural issues, acoustic issues, so on. So the first proposition I want to put forward here is about wood welding. I don't imagine any of you have heard of this, and that's not to patronise you. It's a quite unusual thing. It's quite advanced wood science, but essentially, we've been doing a lot of work taking technologies that have been evolved in Central Europe. Cross-laminated timber came into kind of being in the 90s, looking at using lots of waste wood or overproduction in forestry to make two-way spanning slabs, trying to make very big panels of timber, build whole floors, walls, roofs very quickly. And that's really taken off in the last few years in England, huge amounts of schools, supermarkets, so on are being built with cross-laminated timber. And we've been developing this for production in Scotland from Scottish-grown timber because there are no manufacturing facilities for these particular products in the UK. So it's one way of looking, adding value to our forest resource. So this is kind of generic research, if you like. Dowel timber, Brettstapel, the German word, is connecting stacks of wood with dowels. I mentioned that, but I'll come back to it because the purpose of it here is to talk about wood welding. And the idea here is that you drive dowels in very high speed, rotationally, they're spinning in, and that kind of melts the, well, it welds the timber together. It forms a fusion between the lignin and the wood and the cellulose fibers and wood cells. And we can make very strong joints between the timber. The important thing is that it's, you're not using any glues, you're not using any toxic materials, and it means that at the kind of end of its life, we can recycle the timber, we can reuse it for other things. We don't have to send it for biomass and so on. And it's a very, very efficient and energy-saving manufacturing process. So this is one project that we want to get off the ground because in terms of the other projects I mentioned, cross-laminated timber, Brettstapel, yield stack plant systems, we're learning from Europe, we're learning from what's going on in other places, but we have in our university we have very good quality, very good wood scientists and chemists, and we feel there's a product here that we can take a lead on, looking at hardwood technology and create something that has export potential. And watching this man over here is obviously wanting to get on with it and rush for lunch. Second idea, big issue in the UK at the moment. One of our big imports from Europe is diseases. We have lots of things with trees, the ash dieback, Phytophthora and larch, red band needle blight in Scots pine trees. So what we want to do, we're already doing some work looking at the wood science issues and the structural issues, and what we want to do now is develop a whole range of new engineered timber products from the kind of diseased timber. Rather than just taking it off and burning it, can we create added value from this resource? Now, it's been done in other places. This is in Richmond, near Vancouver. It was done for the Winter Olympics there. It's huge, 90-metre span glulam beams, integrating all the building services, huge structural components. In between them, what they call wood waves, absorbs the sound and so on, but all made from standard sections coming out of a sawmill, and but all made from 6,000 beetle-affected pine trees. So it's an enormous example of what you can do with clever engineering and understanding wood science to create products from a problem. And my third, so the objective for us is to really say what kind of products can we develop, who do we need to work with, structural engineers, foresters, and so on, and timber manufacturing companies. And the third and final example is just simply extending the life of external timber cladding. I mentioned this, it's widely used in buildings, we've done a lot of research, I mentioned we're writing British standards. We've taken timber, we've put it in the coldest, wettest, horizontally driven rain hillsides in Scotland to do accelerated weathering tests. We're working with people in Galicia, looking at all sorts of panel and timber, because one of the big problems nowadays is what you coat the timber with, the colouring, the protection, and so on. A lot of these chemical protections actually don't work very well. And these panels here have been up for about a year. I went to see them in July. There's all sorts of mold growth growing underneath the coatings and everything else. So there's a next stage of work we want to do with the manufacturers of coatings and so on to take this further. So so I'm just bouncing at you very fast before lunch 3 ideas that says these are the things we're interested in. We want to take timber technology in Scotland to a new plane and move forward from the ERDF work we've been doing with lots of SMEs. We're very used to working with SMEs. We like it because it allows you to do applied research and in a very positive way bring things to the market. These are 3 ideas in very different sectors of wood technology. I'm up for it if any of you are. Thank you.